Okay, this is valence electrons and Lewis dot structures as well. I'm going to start with valence electrons, just a definition. The valence electrons are the electrons on the outermost shell of an atom. Okay. These are responsible for all the reactions and charges that we get. Okay, so they're the main players in these two things. So the reactions and charges. So if you're looking at something, if you're looking at an atom, okay, and we know that it doesn't exactly look like this now, right? But let's say you have you've got 2 electrons in the first energy level. You have 8 electrons in the second energy level, and let's say you have 2 in the third energy level. This level right here, okay, that level right there is called your valence shell. Okay, it's a valence shell. The electrons are your valence electrons. Okay, valence electrons. And there's an easy way to determine, which elements have a certain number of valence electrons. All you have to do is look at the periodic table. So if we were to look at the periodic table here, let's draw one real quick. Okay, that's it right there. Okay, not bad. This first column, okay, everything is going to have 1 valence electron. Okay. Second column is going to have 2 valence electrons, 2 VE. Third column, okay, you do with column 3, 4, 5, 6, 7, and 8. Okay, each one of these is going to tell you how many numbers of valence electrons there are. We're going to skip all of these in the middle. Okay, skip the transition metals, which is what these are. All right, and then you can go on down the line. Okay, this has 3 valence electrons, 4 valence electrons, 5, 6, 7, and then finally 8 valence electrons. Okay, the vertical columns are called groups. Okay, so your group number is going to equal your valence electron number. Okay, your group number is going to equal your valence electron number. Now, the group number also tells you, some other different things, but for now, we're only focused on the valence electron number. Okay, so if you were to look at a periodic table, okay, and I asked you how many valence electrons does fluorine have? Well, fluorine is right here. Okay, it's in the 7th column, so it's going to have 7 valence electrons. Okay, if I asked you for, let's say, boron is right here. It's in the 3rd column. It's going to have 3 valence electrons. Okay, and it doesn't matter where it is. It doesn't matter if it's at the top or the bottom. Okay, let's radon. Okay, radon's all the way down here. All right, radon's all the way down there. It still has 8 valence electrons because it's in the 8th column. Okay, so let's move on to Lewis structures. What are we going to do with that information? Okay, Lewis dot structures. Okay, Lewis dot structures. These are representations of the arrangement of valence electrons. valence electrons. Okay? And there's a certain way that you have to write this. So the first thing we're going to do, the first thing you have to do is find out which group the element is in. Element. Okay, find out which group the element is in. Second thing you're going to do, all right, you're going to write the element symbol. Okay, so let's say that we wanted to do carbon. Okay, we have our example down here because we still have to do our third step. So our example here is carbon. Okay, we're going to find out which group carbon is in. Okay, then we're going to write the element symbol. The third thing we're going to do is we're going to fill in the valence electrons. Okay, so if you were to look at your periodic table, all right, look at your periodic table, you're going to see that carbon is in the fourth group. Okay, so we're going to write the chemical symbol, which is a C. And what you need to do is pretend that there's a box around the chemical symbol, just like on the periodic table. All right, and the valence electrons can only go on the flat parts of that box. Okay, you can't put one up in the corner. Okay, it's not going to end up being a circle. All right, and what you do is you start, I like to start on the right. Some people like to start on the left. It really doesn't make any difference. We're going to start by placing one valence electron, okay, on the right side. And then you just go clockwise, okay? You go in this direction right here. All right, so the next one, you've got 4 total. So you're going to have 1, 2, 3, 4. All right, now what you cannot do, or what you do not want to do, okay, it's not a circle, okay? You're not just making a circle. You're not just making a circle around this thing with valence electrons, okay? You're not just making a circle. So that's wrong. All right, keep it on the flat parts of the box. All right, the other thing you cannot do is pair electrons before you've made it all the way around. Okay, so no pairing of electrons before first time around. Okay, so anything greater than 4 valence electrons is going to have a paired electron. Okay, or some paired electrons somewhere. All right, so this one's wrong as well. All right, so let's do another example. Let's say that we've got magnesium. All right, and if you look at your periodic table, magnesium is Mg, all right, and it's in the second column, second group. So you're going to start here, 1, you're going to put the next one there, 2, and there you're done. That's it. All right, let's look at one that has more than 4 valence electrons. Let's look at sulfur. Okay, let's look at sulfur. Sulfur is a chemical symbol of S, and it's in the 6th column, so it has 6 valence electrons. Okay, so you're going to start on the right, 1, go to the bottom 2, go to the left 3, go to the top 4. All right, now we have 2 more valence electrons. Because we've gone around once, now we can start pairing them up. All right, so you've got 4, and then on the right again is 5, and at the bottom again is 6. Okay, and then there you're done. Now what you see here is 2 groups, okay, of paired electrons, all right, and 2 unpaired electrons. Okay, so you have paired electrons and unpaired electrons. The unpaired electrons, this is important for later, the unpaired electrons, these do the bonding. Okay, so when we get into bonding next semester, after Christmas, the valence electrons, the unpaired valence electrons are what do the bonding. Okay, they're what they are, you know, what's involved. Okay, so let's do another example. Let's do radon. Rn. Okay, you look on there and it's got 8 valence electrons. So you're going to go 1 on the right, 2 on the bottom, 3 on the left, 4 on the top, and then keep on going. 2, okay, or sorry, 5 on the right, 6 on the bottom, 7 on the left, 8 on the top. And there you're done. Okay? You cannot have more than 8 valence electrons on a Lewis structure. If you have more than 8, you've done something wrong somewhere. Okay? Now, I said that you cannot pair electrons before you go all the way around. There is one exception. Okay? We're going to talk about that exception. That exception is helium. Okay? Now, the reason helium is the exception, okay, is essentially one reason. Okay? It only has 2 valence electrons. Okay? And the first energy level can only have 2 electrons. Okay? So because of other properties with pairing, you write heliums right like that. Okay? This is the correct way. Okay? That is incorrect. So helium is the only one that you're going to be able to pair these electrons up before going all the way around the symbol. Okay? And the last thing I want to tell you is the octet rule. All right, the octet rule basically says that it's the desire of all atoms to become stable. They want to be stable. They want to be, you know, at a low energy level. Anytime you get something with a higher energy level, it's all excited and then it becomes unstable. So it's the desire of all atoms to become stable. And they do this by getting 8 electrons in their outer shell. And remember, the outer shell is the valence shell. Okay? So even if that means becoming an ion, so let's look at oxygen. Okay, oxygen is going to have originally 1, 2, 3, 4, 5, 6, 7, 8 total electrons, 6 in the valence shell. Okay, 8 total electrons, 6 in the valence shell. All right, it's going to add, because it wants to become stable, it's going to add 2 more electrons. Now that it has 2 more electrons than what it normally does, it is a -2 charge. Okay? So it's happy at a -2 charge because it has these 8 valence electrons on the outside. The same could be said for something like sodium. So sodium, okay, sodium has originally 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. It has 11 electrons. Okay? Now, because it's easier to just get rid of this one than it is to get 7 more, it's going to kick this one out. Okay? And it's going to have a +1 charge. Okay? So this shell is no longer there. And you're left with that shell right there. Okay? So it's happy because it has 8. Oxygen over here on the left is happy because it has 8. And that is the octet rule. It's designed to essentially make the elements happy. Okay? That is valence electrons and Lewis dot structures.